expression for electric potential at a point due to a point charge. Here, our duty to understand how to derive an expression for electric potential at a point due to a point charge. For that reason, consider a point charge. Consider a point charge of magnitude plus q. Plus q. Draw an axis along positive x direction. Consider a point P which is at a distance r, which is at a distance r from point charge located at O. Located at O. In the same direction, consider 2 points A and B. Consider 2 points A and B of distance dx. Of distance dx. Dx. Let these 2 points are A and B. Distance AB is dx. Consider a unit positive charge, that is Q naught, is equal to plus 1 coulomb charge, which is at A, and distance OA, let it be x. That is, test charge is placed at a distance x from the source charge. Here, whatever we have taken, Q is the source charge. Q is the source charge. And Q naught is the test charge. Q naught is a test charge. So, Q is the source charge. Q naught is the test charge. Now, because of the source charge, test charge Q naught experience a force towards positive x-axis, or what we are calling, it is a right side. It is vector E. Vector E. And vector E is given by, already you know that vector E is equal to vector F by Q naught. Force per unit positive charge is electric field. Electric field. Now what we are getting actually here, because of that force, there is a displacement takes place. Depends on the definition of the electric potential is work done in bringing a charge from A to B, or from infinity to the required point through a distance dx. So displacement, it is in this direction. What we are getting, that displacement dx in this direction. Displacement dx in this direction. Okay, this is nothing but what we are getting. Consider a source charge which is at O. Consider a point P where we have to find out the electric potential, which is at a distance r from O. Consider 2 more points on the same axis A and B of distance dx. Because of that source charge, test charge experience a field vector E towards right. By definition of the electric potential, is work done in bringing a charge from infinity to the required point here towards AB. Then force and displacement are anti-parallel to each other. Now, first let us try to write the electric field at A due to the source charge. Electric field at A due to source charge, due to Q. Electric field at A due to Q is given by what we are getting, E is equal to 1 by 4 pi epsilon naught Q by R square. 1 by 4 pi epsilon naught Q by R square. Call this expression 1. Since it is vector quantity, we should represent the direction of this field also, and it is along O towards A. So along it acts along OA. It acts along OA. Okay. Now let us try to calculate the work done when a test charge moves from A to B through a distance dx against the field. That is nothing but work done. Therefore, the work done to move a unit positive charge, to move a unit positive charge, from A to B, from A to B through a small distance dx, through a small distance dx, against the direction of electric field, against the direction of electric field, against the direction of electric field is given by dW is equal to minus of EDX. dW is equal to minus of EDX. Now, how we obtain this formula? We know that since E is equal to vector F divided by Q naught. If Q naught is equal to 1 coulomb, then vector E is nothing but vector F. And we know that work done. We know that work done W is equal to, we know that work done W is equal to vector F dot vector dx, vector F dot vector ds. Why I am explaining this? Because I have written here directly this formula, dW is equal to minus dx, EDX, where dW is the amount of work done, Negative sign indicates displacement and force are in opposite to each other, or displacement and field are opposite to each other, and dx is the displacement. Now W is equal to V ds. Now what you can write, you can expand that. This is given by W is equal to F dx cos theta, F dx cos theta. And already we know that if test charge is q naught is equal to 1 coulomb, then vector E is nothing but vector F, and here theta is equal to 180 degree. The reason, this is the point where A in the diagram, if you think this region, see here, in this region, only concentrate on this region, and in this region point A I have written in this direction vector E, and in this direction vector dx. Here vector A, angle between vector A and vector dx is vector A and vector ds. This is theta is equal to 180 degree. Now substitute the value of F and value of theta. We are getting W is equal to, or I can write it is dW, here also dW, here also dW, and here also you can write dW. dW is equal to vector F dot vector dx. dW is equal to E dx cos 180 degree. Now you know that cos 180, since cos 180 is equal to minus 1, then we are getting dW is equal to minus E ds. So negative sign indicates that force and displacement, or field and displacement, are opposite to each other. Force and displacement are opposite to each other. Okay. Now therefore we got that equation E is equal to dx. Now substitute the value of E. E is equal to 1 by 4 pi epsilon naught q by, it is, we should write it is x square. The reason, test charge which is at a distance x from the origin. So you can write immediately, this is nothing but it is x square. It is x square. Okay, 1 by E is equal to 1 by 4 pi epsilon naught x square, since distance between the source and the test charge is x, not r. R is the distance between the O and P. Therefore the total work done in moving a unit positive charge from infinity to a point against the direction of electric field is, therefore total work done in moving the unit positive charge, in moving the unit positive charge from infinity to a point, from infinity to a point against the direction of electric field is, against the direction of the electric field is, against the direction of electric field is given by W is equal to W is equal to integral of dW is equal to integral of minus E dx. Therefore, W is equal to integral of minus 1 by 4 pi epsilon naught q by x square, that is nothing but the field E, into dx, where x value, x is equal to infinity to x is equal to r, that is the limit. So you should integrate the above equation with respect to the limit infinity to r. Okay. Now, while integrating, remove all the constants outside, that is minus q divided by 4 pi epsilon naught, minus q divided by 4 pi epsilon naught integral of infinity to r 1 by x square dx. Now you should do the side work. How to integrate 1 by x square dx? You are getting here integral of 1 by x square dx is nothing but here integral of x to the power minus 2 dx. Here you should use one formula, and that formula is nothing but integral of x to the power n dx is equal to x to the power n plus 1 by n plus 1. This is the formula. So what you can write here, in this case, therefore, integral of x to the power minus 2 dx is x to the power minus 2 plus 1 divided by minus 2 plus 1, since n is equal to minus 2. So after differentiating you are getting, it is after integrating you are getting, minus 2 plus 1 is minus 1 divided by minus 1. This is nothing but minus 1 by x. Now substitute the value here in case of this expression. Work done. W is equal to minus q divided by 4 pi epsilon naught integral of 1 by x square dx is minus 1 by x to the limit, lower limit infinity, upper limit r. Substitute the limit now. You are getting W is equal to minus q divided by 4 pi epsilon naught minus q divided by 4 pi epsilon naught minus 1 by r minus of minus 1 by infinity since 1 by infinity is 0. If you write since 1 by infinity is 0, then W is equal to, you are getting 1 by 4 pi epsilon naught q by r. So this is the expression for work done. And you know that already we studied potential is given by work done by q naught. Since q naught is equal to 1 coulomb, then potential is nothing but work done. Therefore, you can write here, you can write potential V is equal to 1 by 4 pi epsilon naught q by r is the final expression for electric potential. Okay. Now, in short, you can remember it is V is equal to K Q by R, where K is 1 by 4 pi epsilon naught, is the expression for electrical potential. Is the expression for electric potential. Expression for electric potential due to a point charge. Due to a point charge. So in this video, I explained in detail how you can derive an expression for electric potential due to a point charge. And it is one of the very, very important 5 marks derivation question for Karnataka PU board or central board exam CBSE 11th and 12th. Thanks for watching the video.